Hey guys, Dr. Brown here, and tonight we're going to do the integral of the square root of x minus a over x to the 5 halves, integrated with respect to x. What to do here? When we see a lot of problems, they may have an x squared minus a squared. We'll say, it looks like secant. Well, in this case, I don't have x squared and I don't have a squared. I just have x minus a. So what to do with that? Well, not to be outdone, let's let x equal a secant squared theta. So dx equals a times, bring the 2 down, I'll put it out here, 2 secant theta now to the first power times the derivative of secant, which is secant theta tangent theta d theta. Whoa. So dx equals 2a secant squared theta tangent theta d theta. All right, so let's plug in the blanks here. We have the integral of the square root of x, which we said was a secant squared theta. That's x minus a, square root all of that, over x to the 5 halves. So we're going to break it into 2 pieces. A to the 5 halves, secant theta squared to the 5 halves. And you'll notice 2's cancel. All right. dx, which is 2a, I'll put the 2a out here. Got a big shelf there. Secant squared theta tangent theta d theta. Wow, it's a long problem. Okay, let's get rid of a few things here. I have a divided by a to the 5 halves. So that's a to the 2 over 2, because that's to the first power, minus 5 over 2. This gives me minus 3 over 2. So I have a to the minus 3 halves, which is 1 over a to the 3 halves. Okay? So I'm going to take that 2a and I'm going to wipe this one out. That becomes over a to the 3 halves. All right. What else did we have going on? We had secant squared raised to the 5 halves power. And you know, when you have a to the m raised to the n, that's a to the m times n, which is what we've done here. Okay. Now, since I have secant to the 5th dividing into secant squared, that wipes out that secant squared and makes this one go to the cube. Secant theta to the cube power. Now scoot this tangent theta d theta. I'll scoot it over. All right, now let's factor an a out of this guy. So I'm just going to do it like this. Oh, now let me get rid of the a. What's the square? A to the 1 half. So I'd have 2a to the 1 half. Wipes that guy out. So now I have a to the 1 half minus to the 3 halves gives me to the minus 2 over 2. So it's a to the minus 1 or 1 over a. So all of this becomes 2 over a. Man, we're whittling this guy down. Now, what is secant squared minus 1? It's tangent squared. What's the square root of tangent squared? It's tangent. So I have 2 over a, the integral of tangent. So that's secant squared minus 1, which is tangent squared. Square root of that is tangent. Tangent times tangent is tangent squared theta d theta over secant cubed. All right. What are we going to do with that? Well, secant's 1 over cosine, right? So I have cosine cubed, and tangent is sine over cosine. So let's convert all of this into sines and cosines. So I have 2 over a, the integral of sine squared theta over cosine squared theta, which is the tangent squared. Cosine cubed, or secant, I should say, is 1 over cosine. So since I have secant cubed, I'll move that up to the numerator, d theta. So now I have a cosine cubed theta over cosine squared. That wipes that out. So now I have the integral of sine squared theta cosine theta d theta. Now we know, we're sitting here looking at if u is sine theta, I have u squared. Derivative of sine is cosine theta d theta. So all of this becomes du. So I have 2 over a, the integral of u squared du, and that gives me 2 over a u cubed over 3. So I'm going to rewrite that. That's 2 over 3a u cubed, which was sine cubed theta. Now then, I'm going to move that up here. That's 2 over 3a sine cubed theta. Okay, and we're in the theta world. We've got to get back to the x world. Where were we? Okay, let's write our triangle here. Theta, but x over a equals secant squared theta. So I need to take the square root of everything here. So that would give me secant then is square root x over a, square root a. So secant, you know, is the hypotenuse over the adjacent side. So I have square root x over square root a. This side would be square root x squared, square root x squared, which is x, minus square root of a squared, which is a. Man, that looks familiar. Okay. Now then, so what do we end up with? 2 over 3a sine, which is opposite over hypotenuse. So that's the square root of x minus a over x all cubed plus c. And that, my friend, is the integral of square root of x minus a over x to the 5/2. Okay, interesting problem, simply because it started with a structure that's not common. You don't see it so often. So it caught my eye when I saw it. Okay, why are we doing this? We're practicing our free throws, man. We're trying to get better. We're trying to build a better tomorrow and do that through math. Keep studying, okay? And we'll talk to you next time. Thanks.